Hello again. We're factoring, and we're factoring ax squared plus bx plus c. Basically what that means is we're just putting a number in front of the x squared. And that makes it a little different. There are many ways to do it. You can create tables, and you can use the guess and check method, which I actually think are overall the best because it makes you build up your math. But I realize that some students aren't as good in math as they would like to be. So with that said, you have to try to teach it in a way that at least seems concrete. Because a lot of students that end up taking math, they don't want to keep going in math, they just want to learn what they have to learn just so they can do it. And I can sympathize with that. I also will show a way of doing it by grouping, which is very difficult, but at least it explains why it works. This one's more of a little trick that you can use. And it's pretty cool. It's not terrible. I'll show you how to do it. Hopefully it'll make a lot of sense. Now what you have to realize is when you factor like this, that I'm going to show you, you have to make sure that it's in standard form, so it goes from highest degree to lowest degree, and you have to make sure that you take out the GCF. Otherwise this trick doesn't really work very well, to say the least. So that said, we're going to go ahead and try this. Now you want to split this into two sets of parentheses. Basically you want it to be some quantity times some quantity. And the signs are negative, negative because the last term is positive and the middle term is negative. So that's what I do know. I don't know if it's 2x and x, I don't know if it's 3, I don't know. Let's just say I don't really know. And this one's actually a pretty easy problem, but it even works with more difficult ones, just as long as you end up taking out the GCF, the greatest common factor. So here's what you do. You take the first term and you multiply it by the last term. You take 2 times 3, and then what that gives you is it gives you a 6. So I've got to come up with two numbers that multiply to be 6, but add to be negative 7. So they got to multiply to be 6, and they got to add to be negative 7. Now the choice for that is negative 6 and negative 1. That's the only thing that will work. Negative 6 plus negative 1 will equal negative 7, and it will also multiply to be 6. So let me say that again. Multiply the first and the last term together. That gives you a 6. Okay, I've got to figure out something that multiplies to be this number, but adds to be negative 7. Now here's the little trick. You take the first term, and you write it down twice. But you don't write down 2x squared, you write down 2x. And you write down 2x. Now what you do is you divide by these two numbers that end up working for the product, but also the sum of this number. And you divide them out. So you take negative 6, and you take negative 1. And you reduce it when you can. 2 over negative 6 is x over negative 3. And this is just 2x minus 1 because you can't really reduce it. Now the little trick works like this. Put this one in one of the parentheses, or one of the quantities, pardon me, and put 2x and negative 1 in the other quantity. And there's already a negative there. That's it. 3 times 2x is negative 6x. X times negative 1, negative x. That's all there is to it. Actually, when you're supposed to employ this trick, you're not supposed to even put down any signs. You're just supposed to put down the quantities. So that would mean you put negative 3 and negative 1. For anybody who might have had that question. So let's try it on this more difficult example. Now the problem with this one is that you have to take out a GCF. Well, there's no GCF. 4, 12, and 7, there's nothing that goes into them. And x squared, x, and 7. Well, I agree to an extent, but you always want your first term to be positive. So you can actually take out a GCF, and that GCF is negative 1. You can divide all the terms by negative 1. And what you end up getting is 4x squared, subtract 12x, subtract 7. Close it off, but everything that you pull out, they're trying to pull me back in. It was the Godfather analogy that I used. And here's what you got. Now you want to figure this out. You take the first number times the last number, and that's negative 28. So I have to think of two numbers that multiply to be negative 28, but add to be negative 12. And the answer to that is negative 14 and 2. And then once you get the hang of using this trick, if this is what you want to use instead of tables and just try to guess and check, it really goes much, much, much faster. It takes longer to explain. It's much faster to just do. So here's what I do. I write down this first term, but I don't use x squared. I just use x. I write 4x and 4x. And I divide by negative 14. And well, I'm not actually dividing, it's just a way to categorize it. And I divide by 2. 4x over negative 14 turns into 2x and negative 7. And 4x over 2 turns into 2x and 1. What you do is you write them into two quantities. 2x minus 7. 2x plus 1. That's negative 14x plus 2x is negative 12x, but don't forget the negative 1. And you just factor that. And that works for any type of trinomial, a quadratic trinomial, pardon, where you factor out the GCF first. Like I said, this one and this one you could probably just guess and check and figure it out really quickly. But you might end up getting ones where this number is going to be a 12 and it's a nightmare, and this one would be, I don't know, something that's also a nightmare. 30, and then this is something that doesn't end up factoring out with a GCF. And this way that you employ actually does work out. As I said, I'm also going to talk about it with grouping, which actually has a more concrete explanation. Students don't like it, but at least they get to see an exposure to grouping too, which I like, doing two things at once. But yeah, that's not bad. I find that a lot of students actually like that. I really do think the best way though is to just get faster and guess and check. But like I said, if you just want to get the problem right and be able to at least factor something like this, you can do that. And as long as you practice it, you get better with it. So that's always a plus. With that said, have a good day for now. Goodbye.